Learn Live session on the Intro to Confidential Computing with Azure Virtual Machines. We're delighted to be here with you all today. I'm Ananya Garg. I'm Product Manager here at Microsoft. And joining me today is my teammate, Rakesh.
Hello, everyone. My name is Rakesh. I'm a Senior Program Manager in Azure Confidential Computing team. I'm super excited to be here to share more information about confidential virtual machines that has support for AMD SEV-SNP.
Wonderful. Joining us today is also our lovely moderator, Graham Bury. He's there in the chat. We'd love for you to say hi to him. Let him know where you're from. Today's Learn Live session is on the Intro to Confidential Computing with Azure Virtual Machines. It is also available as a Learn module, and you can scan the QR code to be linked to that. The learning objectives of these two sessions are very similar. So if there's anything that you miss here or you want to go into more detail, we definitely recommend checking out the Learn module with this session. We'd love for this session to be as live and interactive as possible. We'd want to be in a room here with you folks. So let's try to keep that engagement on. Please feel free to ask questions in the chat, say hi, and we'd love to hear from you. Let's get started. The learning objectives of today's Learn Live session is to understand what is Azure Confidential Computing and why do we need confidential computing. We want to go into our offerings of the confidential computing virtual machine offerings. And we'll be specifically focusing on the AMD SEV-SNP confidential virtual machines. This is one of the many acronyms we're going to cover today, so sit tight. And lastly, we'll go through a demo of how do you deploy a confidential virtual machine to help you secure your workloads better. So let's get started with what Azure Confidential Computing is. Rakesh, do you want to take our participants here today in some more detail?
Sure. In Microsoft Azure, the data at rest and in transit is encrypted by default. Technologies such as like HTTPS and SSL will ensure that your data flowing between the public and the private networks is encrypted. Now, when it comes to confidential computing, it gives you, or it's designed in such a way that customers can leverage the additional protection so that your data in use is also encrypted. To understand the benefits of confidential computing, let's take a moment to understand the various attack surfaces that could be feasible in the real world scenarios. If you look into the slide, we have listed out a couple attack surfaces. The first one is the cold boot attack. In this particular attack scenario, assume that there could be an attacker who might have access to the data center, and that attacker will be in a position to retrieve the memory from the node where the sensitive data might be running on it. Coming to the second attack scenario, this is the zero-day vulnerability. Assume that there could be an attacker who might have access to a zero-day vulnerability. In that case, that the attacker might be able to actually trick the hypervisor in such a way that he or she could be able to retrieve the other virtual machine memory. I have to caution that both of these attack surfaces are not very common. In Microsoft Azure and the other cloud providers, always the security is at the top-notch level. But we need to understand that when we run our sensitive workloads, either in the cloud or even in the on-prem, we need to make sure that we do have protections against such attack surfaces. This is where the confidential computing comes into the picture. Confidential computing provides the capability so that your data, while it is in use, is protected. Without the confidential computing, if you actually run your data while it is in use, that encrypted data will be unencrypted. But by leveraging the confidential computing technologies, it ensures that your data could be run in a trusted execution environment. In this case, when it comes to the capabilities of confidential computing, it provides the capability of having memory being encrypted so that your sensitive data gets additional protections.
Perfect. So we understand why confidential computing is necessary and how it is in addition to the world-class measures that Azure is taking. Azure is the leader in confidential computing, and we have the broadest set of offerings in this domain. Today, we will be focusing on the virtual machine offerings in the confidential computing suite. We have two offerings within virtual machines. One is the AMD and Intel confidential virtual machines, where the entire VM memory is encrypted. And this encrypted VM memory forms the trusted execution environment, as Rakesh pointed out, or the TEE. And this is where you will be running your application. The other virtual machine offering is the Intel virtual machines with the confidential app enclave, where inside your VM memory, you have another app enclave where you will be running your applications and processing your data in a secure manner. For our today's session, we will be specifically focusing on the AMD confidential virtual machines. Rakesh, is there a way for our participants here to choose between the different confidential VM offerings when they're deploying them on the portal?
Absolutely. When it comes to the VM deployment, if customer prefer to leverage one of the VM SKU that has support for AMD SEV-SNP, then we have both DCAS and ECAS v5 virtual machines. The difference though is with DCAS v5 virtual machines, it is more intended towards the general purpose workloads, while ECAS v5 virtual machines are more intended towards the memory optimized workloads. If customer prefers to leverage a virtual machine that has support for Intel GDX, then we do have DCESP5 and ECESP5 VMs. Just note here, these VMs are currently in preview. And when it comes to the virtual machines that do have support for app enclaves, we have DCSV2 and DCSV3 VMs. One difference between DCSV2 and DCSV3 is if you leverage DCSV2, you do have the virtual machine that has capability for Intel Software Guard extensions, but it's running on a Coffee Lake processor. If you prefer to actually run your workloads on a next generation processor, then you should choose DCSV3, which runs on the Ice Lake processors.
Amazing. That simplifies it for our participants here. I think it's time for a knowledge check. And this is a place where we would be asking you a question based on everything that we've learned so far. And it's a great place for you to ask us questions too. We'd love to hear from you and we'd love to answer some of the more popular questions on video. So do drop in your questions. The first question is on the screen. You can scan the QR code or vote at the link that we've highlighted here.
A quick reminder, just to recall what Ananya said before, when it comes to the confidential virtual machines, the trusted execution environment is the whole virtual machine because your virtual machine memory is encrypted. While in case of virtual machines with the app enclave support, you have the key to be the app enclave. So that might give you some clue to actually answer the question.
We're cheating over here, Rakesh. We do have a question here from our audience. I think this might be a good time while folks answer. Does the memory encryption affect performance? Rakesh, do you want to take that?
Yes. So there is a penalty when you run your workloads on confidential virtual machines, but this penalty actually do vary between the type of workload that you'll be running on your confidential virtual machine. Uh, in general, we would see like 2% to 3% hit when you actually run your workloads. But as I said, it varies depending upon the workloads.
Perfect. Thank you. I think it's time to see how well our participants have understood what a trusted execution environment is. Let's see what the results are like.
Do you have any other questions from audience at this point in time?
Not at the moment. I think we can move on. Let's answer. Let's see what the answer to this question is, and we'll come to the results when they're available.
Sure.
I'll just maybe check one last time if I'm able to. Okay. So the answer for this one is that trusted execution environments enforce execution of only authorized code because that is what we want to be running in the encrypted virtual memory, virtual machine memory. So we have another question coming up for our knowledge check. Once again, you can vote either at that link or by scanning the QR code.
I think this should be an easy one.
Yeah. Okay, I do have. Okay, not yet. We're still waiting on a couple of folks to answer the questions. So let's give folks maybe one more minute, Rakesh. This is a tough question.
Sure.
Okay, so the answer for this one is option C, which is that it's a capability incorporated into a portfolio of Azure products designed to meet trust and security requirements for sensitive workloads. As we had mentioned, Azure Confidential Computing is the leader in confidential computing. And so we have only the highest trust and security requirements when we include a product into our portfolio. Let's move on. Uh, as we had discussed that today we will be covering the AMD SEV-SNP confidential virtual machines. Rakesh, do you want to take our participants through what are these confidential virtual machines?
Sure. As Ananya pointed before, Microsoft Azure is the leader in the confidential computing workspace. We do provide various set of offerings that includes virtual machines, the platform services, and also the container offerings as well. When it comes to the virtual machines, for this session, we'll be focusing more on confidential virtual machines that has support for AMD SEV-SNP. This is where the data protection at runtime comes into the picture. This is the data protection at runtime is indeed powered by the underlying CPU. In this case, it's AMD, and the
Mm-hmm.
technology that facilitates this capability is the secure encrypted virtualization and secure nested paging. If you're not familiar with this technology, AMD started off with SEV, which is secure encrypted virtualization, and then
Mm-hmm.
later technology has been advanced towards ES, the encrypted state, and secure nested paging. In summary, both DC ASP5 and EC ASP5 virtual machines have the memory and the CPU state protected. In case if you're questioning what is the core component which actually provides these capabilities, there is a platform security processor, which is a dedicated ARM-based core processor that provides various protections. Among those protections, couple protections that we would like to highlight is the runtime protection and the
Mm-hmm.
platform authenticity. With runtime protection, there is a memory encryption engine which is embedded within the memory uh, controller, and which ensures that the memory is encrypted by default. And that's one of the core benefits of running your sensitive workloads in confidential virtual machines, because the virtual machine memory is encrypted by default. And the second protection, which is enabled by the platform security processor, is platform authenticity. By it, the processor itself provides a version chip endorsement key certificate. The summary there is the guest VM, in this case, the confidential virtual machine guest VM, will have the capability to do the guest attestation and know that they are indeed running on the right hardware or not. Now, when it comes to the VM deployment workflow, the most important thing is, depending on your requirements, you need to make sure that you choose the right VM SKU. In this case, if you prefer a VM SKU that has support for AMD SEV-SNP, then pick DCAS v5 or ECAS v5.
Amazing. So we see that we can leverage AMD SEV-SNP hardware just by ensuring our type is confidential compute and we pick from the DC and EC series SKUs.
That's right. Yep.
Wonderful. Rakesh, do you want to explain to folks here why OS disk encryption is essential?
Yes. So we covered couple attack surfaces before. One of the attack surface was the zero-day vulnerability. So in that particular attack surface, we assume that there could be an attacker who might have access to a zero-day vulnerability so that they can actually trick the hypervisor. In summary, there, like your hypervisor or the host where your guest VM might be running could be malicious. To ensure that your secrets that might be residing within the root volume is protected, make sure that your root volume is encrypted. So the next question comes to the table is like, how do we actually enable this OS disk encryption while creating or deploying a confidential virtual machine? If you look at the screen, you see there is an option, confidential compute encryption. By clicking that option, it ensures that OS disk is encrypted. There are a couple ways on how to do this encryption. If you choose this particular confidential compute encryption, that request actually goes to the cloud provisioning service, and that cloud provisioning service does the OS disk encryption for you. It's invisible to you, but you have the capability to do the OS disk encryption so that the hypervisor will not be able to retrieve any sensitive information from the OS disk. But from the customer standpoint, if you prefer to do the encryption, then we also provide a CVM provisioning tool, which is CPT, where by leveraging that tool, you can do the encryption on-prem, and then you upload the image to the Microsoft Azure Marketplace, and then you can do the virtual machine deployments. Either way, make sure that you also enable the OS disk encryption while creating your confidential virtual machines.
Perfect. Let's understand why we need to enable secure boot and virtual trusted platform module as well.
Yes. So far we covered the technology that enables the confidential virtual machines, and then the need for having the OS disk encryption.
Mhm.
Now we might question, like, since the root volume is encrypted, where do I actually store the key to that particular root volume? This is
Mhm.
where the virtual TPM comes into the picture. There is a guest firmware where it provides this virtual TPM device so that you can actually store the key to that root volume inside the virtual TPM. That's actually sealed with a particular platform configuration registry policy. Even when it comes to the platform attestation and the confidential virtual machine boot workflow, the volume key is only extracted if and only if the VTPM has the storage root key that matches up with the public key that is used during the initial volume key sealing. And the PCR values should also match.
Mhm.
The point here is, you have the virtual TPM that is associated to the confidential virtual machine, and you also do have the capability to leverage or seal secrets inside the virtual TPM.
Perfect. It seems like we really need this. Is there an easy way to enable this on our portal?
Yes, while creating the confidential virtual machine, you do have the option to enable both virtual TPM and the secure boot. Uh, you can see on the slide, just make sure the security type is click for confidential virtual machine, and also the enable secure boot and enable virtual TPM is set to yes, so that you you know that virtual TPM is enabled for your confidential virtual machine.
Perfect. That makes deployment pretty seamless. What happens once we click the deploy option?
Yes. So we have covered the various technologies that are relevant for in the context of the confidential virtual machines.
Mhm.
Now, once you choose the OS disk encryption, make sure that uh, you picked up all the necessary settings while creating the virtual machine. Once you click the deploy, that request actually goes to the first step is actually goes to the cloud provisioning service. The CPS does two things. One is either encrypting the OS disk encryption, given that
Mhm.
we have chosen to enable OS disk encryption. The other thing that the CPS addresses is the creating the virtual machine guest state. This is required to actually seal some of the secrets necessary during the boot workflow. And once during the boot workflow, all the validation succeeds, the
Mhm.
bootloader is enabled to unlock the disk encryption key. The key is actually used during the VM boot workflow, where you see the key management, where you have the option to choose either the platform managed key or the customer managed key. With platform managed key, Microsoft Azure creates the necessary keys, which make sure that it leverages to decrypt the virtual machine guest state during the boot workflow. But if customer prefers to use their keys, then they
Mhm.
also have the option to choose customer managed keys.
Perfect. That makes sense. So I know that I've done all of the good work on my portal side to ensure that I have chosen the right hardware. I've enabled all of these settings. But what's the way to ensure that once my virtual machine is deployed, I have like none of the settings changed, and I am confident that the OS disk that I had uploaded, that's the one that I'm getting on my virtual machine.
Yep. So once confidential virtual machine boots up, you, customers might want to know that whether they are indeed running their virtual machine on the right hardware or not.
Mhm.
So attestation is a mechanism which helps customers to verify the trustworthiness of that confidential virtual machine. There are several ways that they could accomplish this guest OS attestation. One is through the Microsoft Client Library, and the other method is by leveraging the Microsoft VM extension. In either case, what happens is the library or the extension will collect the necessary attestation information from the guest VM,
Mhm.
and then it passes that information to the Microsoft Azure attestation service. And then it validates that whether it is indeed running on the right hardware and with all the settings on or not. In case if you do have a requirement to make sure that you don't want to take a dependency on the Microsoft Azure attestation, then we also have a way to actually fetch and verify the raw reports through the Paravisor. uh,
Okay.
we do have a blog post which details all the steps on how to actually fetch and verify raw reports. But at a high level, you see on the slide that you need to install a TPM2 TSS library and then obtain the virtual chip endorsement key certificate. If you recall that I did mention about V6 certificate during the platform authenticity. That's where the processor provides the certificate. And then you
Right.
could extract that raw SNP report from the virtual TPM. And there is also an open source tool from AMD, which is ACV tool. By leveraging that tool, you can authenticate or get the report stating that whether the confidential virtual machine is running on the right hardware or not.
Okay, perfect. So that's a wealth of information. I'd like to summarize that a little bit. We
Sure.
understand why we need the AMD SEV-SNP hardware and what are the capabilities that are provided by the platform security processor. We also understand the need for an OS disk encryption so that our OS disk is not being tampered by either the host or the hypervisor, and the importance of secure boot and virtual trusted platform or the VTPM. And lastly, we understood why platform attestation capability validates that the boot workflow has not been changed. and guest OS attestation so that I can verify that I'm truly running on the AMD SEV-SNP hardware.
Yeah,
That's very good end-to-end knowledge, right from choosing the SKU to deploying it. Thank you,
that's right.
Rakesh. We're in time for a knowledge check, right? To see if we've brought all of our audience along with us and they've understood it as well as I have. So your next question is up, folks. We'd love to see your votes either on the QR code or on the link. So let's give folks a couple of minutes. Once again, this is a great pause point. Any questions that you may have, we can definitely help answer them. So do leave them in the comments. I see Graham's been really active in our chat. So thank you, folks, for keeping this so interactive.
Thank you, Graham.
I see that folks are choosing between option B and option A. That's interesting. Rakesh, do you want to take folks through which would be the correct answer?
Sure. If you wanted to quickly run and test a virtual machine with confidential memory for the entire VM, that's where the answer lies. The
Yep.
technology would be the virtual machine level confidentiality. But if you prefer to have, or if you want to have a trusted execution environment, which is a less trusted boundary zone, then that's where the application enclaves come into the picture. Application enclaves help when you prefer not to trust any process that might be running within the virtual machine as well. Like if you need additional protections, assuming that there could be a malicious process that might be running on the virtual machine, that's when it provides you the highest security posture. But there is a huge advantage of leveraging confidential virtual machines. You can just lift and shift your workloads to confidential virtual machines. And then on top of that, you get these benefits of having the memory encryption enabled by default.
Got it. So you decide whether you want to go for an application enclave or a virtual machine level confidentiality based on your workload. Like if you want to lift and shift existing workloads, then it's option B. But if you want to narrow it down and you only want to protect your applications, then you'd use an app enclave.
I would say, in case if you prefer um, a higher security posture where you assume that there could be an attack, or you don't even actually trust some of the users who might have access to the virtual machine, then there is a need that you might want to rewrite your application in such a way that you split the sensitive and non-sensitive parts of your application and run your sensitive parts within an application enclave. But if you already know that, hey, you are giving access to your virtual machine to only the trusted admins, then I would suggest that let's leverage the confidential virtual machines, because there is no need to rewrite your application in case of confidential virtual machines. That's a huge lift off, right? Like for me, it's if I don't need to worry about like rewriting my application again, it's easy for me to just actually install the application, and then application renders the data and you have all these protections.
Perfect. Makes sense. Um, Given that we have just spoken about lift and shift and how easy it is to move our workload, we are in time to see a demo of deploying a confidential virtual machine in the Azure portal. So this is my setup. As you can see, I am in my Azure portal and I will be creating a resource, which is the virtual machine resource. Here, I can choose any existing resource group that I may have, and you can have confidential virtual machines and non-confidential virtual machines in the same resource group. For the purpose of this demo, I'm creating a new resource group, but this is a completely optional step. Here I am giving my virtual machine a name. From a regional availability perspective, we do have another slide on this, but we are currently available in 5 regions, and we have many more regions that come up every quarter. Our current regions are East US, West US, North Europe, and West Europe, and Southeast Asia. For the purpose of this demo, I am choosing East US. Rakesh, which of these regions do we have availability now in?
Currently, the East US region do have support for availability zone, which means that you can get support for AZ01 and AZ02, but you can check through CLI in which availability zones we already have the support.
Perfect. Next, we want to choose our security type as confidential virtual machine. And this is where we really start to get the goodness of a confidential virtual machine, which is we can now see that secure boot and virtual TPM will automatically be enabled when we move along in the creation of our confidential virtual machine. But this is the most important step of getting a confidential virtual machine deployed. We have a variety of operating system images available for our confidential virtual machine. And the easiest way to filter them is by choosing the security type as confidential. This shows you only the images that Azure has deemed confidential and doesn't just filter based on name.
Ananya, one quick comment here on
Yeah.
the images. So currently we have a subset of images that are tagged as confidential and that has the capability to use it for your confidential virtual machines. I do want to state that we also have the Red Hat Enterprise Linux server image that is currently in the tech preview. So we just announced during the build, in case if you do want to leverage the Red Hat Enterprise Linux server image, please feel free to actually sign up for the preview so that we can actually allow that subscription. And also on top of that, if you prefer any other endorsed Linux distribution image, please feel free to share through comments, or please let us know that you have a requirement for a particular endorsed Linux distribution image. Thank you, Ananya.
Perfect. So as you can see from these images, I'll choose the Ubuntu 2204 confidential VM image, but you can choose what your workload supports. Once I ensure that I have the correct image and security type, I will now be choosing the SKU size. And this is something that we've covered in detail before. Once again, I will ensure my security type is confidential compute, and we have the DC ASV5 and EC ASV5 series. And just to iterate, DC series are for general purpose workloads and EC series are for memory intensive workloads. So you will choose the offering that suits your workload the best. For my demo purpose, I have chosen a DC16 ADS series. The next part is very standard Azure administrator account information. You can log in with a password or an SSH public private key pair. I have chosen the public key pair and I'm using the default username. For the port rules, again, this is completely based on your workload. I wanted to run a web server on my confidential virtual machine, so I've also opened port 80, but that is completely optional for you. This is our next key place of importance, wherein we will be enabling confidential encryption. And you may see a different name in a few weeks as we rename it to OS disk encryption. And that is just to always make it very clear and very easy for our customers and our participants here to know what are the options that they're enabling on the portal.
Yep. As Ananya pointed, I know there is a confusion because we say confidential compute encryption here.
Mm-hmm.
We covered about this particular topic in detail. It's about the confidential OS disk encryption. So there is a PR out there, and you will see confidential OS disk encryption in future listed.
Perfect. This is the key management where Rakesh had spoken about choosing a platform managed key versus a customer managed key. And I trust Azure, so I'm going ahead with the platform managed key, but you do have the option of managing your own key here. For the networking, once again, you can use any existing virtual network. You can have confidential and non-confidential virtual machines on the same VNet, and we have it completely integrated. I am creating a new virtual network here only for the purpose of this demo, but it is completely optional. And as you can see, I can keep all the default values and continue with creating a confidential virtual machine. These are some more of the checks that you will be going through to ensure to just validate some more features. And now we are ready to review and create our confidential virtual machine. So just to reiterate a couple of points that you want to be mindful of is that you can now see secure boot and virtual TPM are enabled. Our confidential type is, our security type is confidential virtual machine, and our disks are as we had created them in the previous section. If folks have any question on why we've chosen a particular offering, why we ticked a certain box versus not, please feel free to ask them. And that's it. We're ready to deploy. Here is where I will be downloading the private key, and I will be storing it in my downloads folder that I will later use when I'm logging into my confidential virtual machine. So here, my deployment is now complete. I will be taking the public IP address, and this is what I will use when I'm logging in. I'm just once again ensuring that my networking, my disk, and my security setup is all done correctly. This is another place where you can ensure that your security type is confidential and you have enabled secure boot and virtual trusted platform module. The workload that I wanted to run needed me to open a couple more inbound ports. So that is why I am changing that over here. But again, this is a completely optional step based on what your workload requirements are. With that, I'm now ready to log into my confidential virtual machine. I will be SSHing into it using the Windows PowerShell. I'm using the -i identity option where I will be linking it to the certificate the key pair file, the private key or the .pem file that I had downloaded. And my username is the default Azure user. And I will be logging into the public IP address that I had copied from the overview tab. And just like that, I am now logged into a confidential virtual machine.
Thank you, Ananya, for showing how easy to deploy confidential virtual machine in Microsoft Azure. I know for this purpose, for this particular demo, we have chosen to leverage the Azure portal. There will be customers who prefer to use either CLI, PowerShell, or the ARM templates for their deployments, depending upon their choice. They need to make sure that they choose the right security type, the right confidential virtual machine image, as well as make sure to enable the OS disk encryption to make sure that you have those additional protections. Now, when it comes to the region availability, this was one of the hot topics. We have been getting requests from various customers asking that they need the confidential virtual machines to be available in other regions. As Ananya pointed out before, we are currently available in 5 regions, but we are soon coming to Switzerland North, Japan East, Central India, and Italy North. And on top of that, we also have requests for other regions, and you expect more announcements to come soon in the context of other region availability as well.
A truly global footprint for our confidential virtual machines.
That's the North Star goal. Yes, we want to have confidential virtual machines in every Microsoft Azure region. Yep. Now, coming to the support for confidential virtual machines, I'm actually super thrilled to see all the updates and the progress we have seen in the context of confidential virtual machines. These updates have been coming from the partners, from ISVs, and from customers. I have seen a lot of momentum at the upstream Linux community as well. But overall, just to trim it down to a few announcements, during the Microsoft Build 2023, we have announcements from Azure Databricks where they have announced the availability of AMD-based Azure confidential virtual machines. And also from the product side of things, the Custo/Azure Data Explorer do have the option to leverage ECAS, the confidential virtual machine that has support for AMD SEV-SNP.
Mhm.
Now, when it comes to the partner news, Habu actually delivered the clean data room solutions that indeed underlying technology it leverages the confidential virtual machines, and also the SAS is set to include the confidential VM capability. Overall, I'm super happy to see all the partner updates and the product announcements that we are seeing in this space.
Wonderful. And I think this truly shows that confidential virtual machines are becoming a part of both services within Microsoft and products outside of Microsoft. And this is in line with what we envision confidential computing to be. We believe that confidential computing is the future of computing. And we have many more such associations with other third party products, which you can read in the last link over there, which is aka.ms/ACC stories. We have We've only covered the confidential virtual machine portfolio today, and that too only the AMD SEV-SNP offering. We have similar offerings from Intel, and we have a whole other portfolio which goes into our confidential container compute offerings. So we encourage you to check these out to explore the confidential computing portfolio a little bit more. I'd like to summarize what we have covered today. We understood the importance of confidential computing and why we need it over and above what Azure offers to protect our sensitive data while it is in use. We understood in good detail about the AMD SEV-SNP confidential virtual machines and how the different parts of that hardware enable us to protect our workloads. And lastly, we saw that deploying such a confidential virtual machine is as simple and as seamless as deploying your regular virtual machine on Azure. And so we really hope that looking at the demo and looking at the features that are available, you are inspired to go ahead and try deploying a confidential virtual machine today. As I had said, we also have a Learn module for this, and we have more information and resources available at this link on the screen. You can also scan the QR code to be linked to these resources. And lastly, don't miss the next Learn Live session. It will be to distribute your services across Azure Virtual Networks and integrate them using the virtual network peering. I know I'm going to be tuning into that one. What about you, Rakesh?
For sure, I'll be there as well.
Great. Thank you all again for joining us today. We'll be here for maybe a couple more minutes to see if there are any more of these questions that we can answer or any of the comments that you folks may have left for us. Thank you again for joining us today.
Thank you, Ananya. Thank you, Graham. Thanks, everyone.
Thanks, Graham, for your help in the chat.